Today you are in a different room. You have a
Yeah,
department.
yeah. Sometimes I'm in my small wardrobe, sitting there, and there I have a monitor. So today I thought that I don't need a monitor. That's why I'm here in the living room. So now I'm leaving. So I watched a video of one guy, and he said, "Well, this is my living room, but there is not much of a living in here." So it's
Oh
not.
my god.
So this could happen. Mm, well,
Hey, it's
I guess
10.
it's 10 a.m. Yeah. Hello, everyone. Happy Saturday, as our well-known friend Akash would have said. Yeah. So welcome everyone to our XTechnology session, which we call a code hour. So that means that this will be an hour that we spend on something without too much of a preparation. So it's kind of a live thing. So usually it's about either coding something or building a small prototype or just talking. And today I think it's mostly going to be about talking.
Blah blah blah.
Yeah, blah blah blah, or kind of this. And so today it is the mock interview of ML system design. That means that Annalisa will be an interviewer and I will perform as an interviewee. And Annalisa will give me a task to build some system which involves machine learning. And my task will be like to go through many aspects and think of them and present them. So like in the end that we could think that we planned this solution in a nice way. Yeah.
Yes.
Yeah, and yeah, well, so you all know Annalisa. That's our amazing guest expert. Still, she is. I have to say that she's a
Always here.
guest. Yeah, but I think you already shouldn't be called a guest. So you're just an expert in this technology. Yeah, and yeah, I'm Igor. I'm back from a small break.
Back from vacation.
Yeah, I was on vacation. Exactly right. It's always nice to say I was on a break because I was on vacation. Cool. Yeah. So I guess we can start the content of the meeting, ML
Yes.
system
Let,
design.
let's do it.
So, Annalisa, the
So
stage is yours
just
for now.
yeah, so I mean as we did already one of these and just a short intro that a lot of times when during an interview cycles, especially with big companies, one of the interviews is called ML system design, and you're just presented with a potential new product or a product that already exists but you want to improve, um, and you have to basically guide the interviewer through how would you go about building a machine learning system. So today I am a new founder of an Italian startup called Negozio. And Negozio is an online shop for individuals, right? So single persons can post their products, and this way they can get other individuals to buy. And they each product is needs to have its own listing. The listing will need to contain, of course, a description, the status of the product, and so on, and a few pictures. So let's say minimum 2 pictures of the product. And we have a strict regulation, so we told the user what they can and they cannot post. Among the things that they cannot post, of course, there are dangerous items. For example, zum Beispiel weapons. And yeah, and they of course agree and sign that they won't sell dangerous items, but we don't want to risk it. So we want to make sure that the items that they upload, they list, are not dangerous, are not forbidden items. And we are a new startup, so for now we do not have any machine learning AI capabilities. And we have heard that AI can help. So we don't have we don't have the funds or resources to hire people that check every single. We have some resources to check, but they of course cannot. We are growing fast. They cannot check every single item that is posted, and so we would like to use AI with
Mhm.
this goal.
Great use case. So
Yeah, how would you go about this? Help
cool.
negozio.
Yeah, negozio. So negozio, as far as we talked, that means trading or shopping. Shopping.
Just shop.
Shop. Ah, just shop. Okay, because I like the name. It's negozio.it or
IT, yeah.
awesome. Negozio it. Yeah,
That's it.
perfect. Yeah, so I will recap what I've heard. So we have this website where people will register, I guess, from both sides. So you're either a seller and you're a private individual, you're not a company. And I guess it will be mostly about, I don't know, private things like something that you have at your home and you want to sell, or something that you made with your hands.
Yeah, exactly.
Yeah, and on the other side, there will be also private individuals trying to buy. And there is, as you said, a listing page which contains the details of the product. So when you post an ad as a seller, you probably say which category it is, and I guess Negozio will try to somehow limit you, like put in some
Mhm.
ranges. That this is, for example, yeah, something for keeping the house, like I don't know, for cleaning. And then you will try to specify that more. So you will create a description. So this is my vacuum cleaner. It has that power, and it is maybe 1 year old, and it works nicely. And you say the brand and some maybe numbers about it, and then you post the photos. So I said minimum two, and then I guess you click the button upload or start an ad,
Mhm.
and probably in this moment our potential system should jump in and try to check whether anything is wrong with this potential ad. And if it thinks that something might be wrong, I don't know to what extent. But let's say we have a green, orange, and red. So green is definitely not a problem, and orange is potential one.
Mhm.
So then it should trigger some alarm, and I guess this alarm, it's yeah, based on this color, something different should happen. So I guess if this is definitely something red by the model's opinion, then we should stop this ad from going further. And I don't know what next business action will be, like to contact the seller. I guess yeah, it's always nice to contact the seller. That's why our model decided that your item is prohibited. Please comment on this. And maybe if it's orange, then we're not super sure. Maybe we could utilize some human labeling. You said that we are a startup, we don't
Mhm.
have enough power, but there are services like Amazon Turk or something similar. Actually, I think Amazon Turk won't help us because we need something live. Yeah. Mm. Yeah. Well, anyways, let's say that we.
Let's say we have a few resources that can check the orange. We can put it on pending for
Yeah.
a few hours.
Yeah, exactly. So we can say that sort of we're double checking pre-moderation, yeah, and then we will use some resources and they will try to double check. Yeah. So like yeah, as an ML task, we need to build this model which will output us some probability or some this color class like green, orange, red, and yeah, all our next actions will be based on this. Okay. Yeah. So I'm thinking what else in terms of the task is around. Mhm. What could help us? So you said that there are always at least two images, so that means that we always has something to look at, right? And
Yes,
this, yeah, and the description, I guess it also should be present, right? At least something.
it has to be
Mhm.
present. Yeah.
Yeah,
Unfortunately,
and
it's not minimum number of words for now, so it could be very short, but
mhm.
it has to be present.
Yeah, and also I guess there should be some necessary metadata, like as we discussed, like the class of the product. at
Yes.
least.
And the status, so is it new, like new, used?
Yeah, right. So and
When the
maybe.
product was bought and so on. Yeah.
Mhm. Yeah. Yeah, I guess we're not so advanced yet to start adding additional meta features based on the class. Like, I don't know if it's a vacuum cleaner, what exact power it is. So this thing will be just in the text if
Yes.
people put it. Yeah. So yeah, we have basic metadata. We also know like maybe the like IP of the person who posted it,
Mhm.
like the geography, and I don't know yet how to use it, but maybe if so your website is for Italy or for Europe or for the world?
For now, we target the Italian market.
Hmm. Okay, so maybe this could be also checked. So if people from some very far country will try to post some weird things in Italian market, it also could be a flag.
Mhm.
All right. Mm, okay, yeah, I think I'm already talking about the data, what data we have. So
If I
I think.
understand correctly, your idea is to put this check for dangerous items uh, with the upload button, right? So we will score each listing.
I think yeah, we can go here in probably at least two different directions. So we either can do this, yes. So the user puts all the details that he or she knows, clicks the button, and we do pre-moderation. So and while pre-moderation, first the model runs, and then based on the model results, we either send it forward if it's okay, or we send it to like labelers, and it takes some time. Otherwise, we can always send the item to sales, like right after the upload button, and we can do something in the meantime, like in the background.
But I like the first option. I think
Yeah,
the
yeah,
sales.
it's less risky, yeah, especially now we don't have. But we just started, we should be really safe. Uh, yeah, so yeah, so I guess the kind of business part of the task is quite clear. So we have the input, we run the model, and based on it, we do two
Yeah.
different actions, either right away on the online or we recheck with a human involvement. Then, yeah, so the data, we already started talking about it. What we have a bit of metadata for the product. We have the description, which is text, and the image. Yeah, so I guess the text and the image could be our main sources of information
Mhm.
for the
Agree.
potential modeling. Um, I guess we can maybe start slow and start from text for now and metadata. But yeah, but let's see. And what data else? What else do we have? So I mean, first of all, to build a model, we need to have some data, like ground truth data.
Mhm.
So that means, and probably we don't want to collect this ground truth data at our shop, meaning that for 1 month it just runs and then we close it because of some regulations.
Mhm. Yeah.
So yeah, that means that we either have to find some similar data sets from Amazon or Facebook, I don't know, or we have to create our mock data set and hire some people to label it. So
Mhm.
in that way, we will have some preliminary model or preliminary data, not yet a model. And yeah, so um, I guess yeah, this is like a chicken and egg problem. So if we don't have anything, it's hard to start. Maybe if I just can imagine, maybe as a what's the name? I forgot the name of our shop.
Negozio.
Negozio, yeah. So maybe Negozio starts really small and slow, and you open like one vertical, which is more or less safe. I don't know, which has I don't know plush toys and
Okay.
something else, and slowly and gradually you start collecting the data, and in that way it will be easier to get it for the next modeling.
Mhm.
Yeah. Anyways, you will have to check whether the people are not posting something bad, but maybe in that regime you can do it close to manual. Of course, it's a lot of work, but in that way we can collect a real data set which is about your website. Because, yeah.
Okay.
Mhm. And so when we let's say we somehow collected this data.
Yeah, let's
And,
assume we have the data. We have
Mhm.
either created a synthetic data or found the data or ran the negozio slowly and collected
Yeah.
the data.
Yeah, so let's say now we have a data set, and again there are three types of features for per every item. So the metadata, the description, and the image.
Mhm.
And since we're doing something which is a classification, so we want to say whether the object is good or bad. I mean, yeah, I guess we don't need additional classes. So we just want to classify like the probability of the project being potentially bad. And I guess for these kind of things, the classification model will work. So we will, as an input, we'll put all these features in some way, not yet sure. And then the model will tell us will output the probability of which will tell us how potentially harmful this project is. Oh, sorry, product. Yeah. So
Mhm.
the data. So I'm thinking, should we also collect some customers' data? I guess it will make sense, right? Because I think that if you want to post the product on the website, you should be registered. Otherwise, you probably won't be allowed. And in this case, you have at least some details. I don't know what you will ask from the person about registration, but maybe date of birth, or I don't know, maybe it's not necessary, gender or geographical location, at least something. And the very obvious idea is just to see how a person is behaving from time to time. So
Mhm.
if they post normal products, then we can use this information and tell the model that usually it's okay. Otherwise, yeah, I mean, if it's something bad happening, then we know that it's wrong. And yeah, also most definitely people will give their number, mobile phone number, I guess, and the email. And I think that you can at least try to find some blacklists of numbers and emails in the internet or so. And that could be as a potential signal
Mhm.
of a harmful product. So that's, yeah, a bit of a customer data. Mm, I think it doesn't really make sense to try to analyze the behavior of the customer, like what. Uh, so if the customer is about to sell something, it doesn't make sense to see what they were trying to buy before and try to analyze it. I I think it's just unnecessary. So yeah, we can just look at the previous sales.
So to recap, you have data about the customer,
Mhm.
metadata about the object, text, and image. And you
Yeah.
want to predict good or bad. So you want
Mhm.
to have only these two classes.
What I want to output is another class as a probability, yeah, but
Yes.
this kind of range will change from good to bad. Yeah.
Mhm.
Um,
Okay. How would you
yeah.
combine text, image, and metadata and user data in this
Mm,
classification?
yeah, that's a great question. I think I would start slowly and try to build a model based on maybe I start from the metadata and the text. I will just leave the image a bit aside for the first iteration. And so for the metadata, it's more or less understandable. It's either, I don't know, it's either a categorical feature where, like you say, the type of the product, where you have like 10 classes or 20 classes. Uh, yeah, then there is like a mobile phone number and so on. And then there is a text, and we have to somehow process this text to be able to put it into the model. So that makes we need to embed this text into something, into
Mhm.
numerical features. And again, I think I will start slow and do something like TF-IDF, I guess, or even back and forth. So just try to apply these quite old but powerful techniques, which
Okay.
will split the text on items and process them a bit. And basically, the idea here will be that if in the text there is some word, I don't know, weapon or gun, that probably will be a bad signal for the model. So this
But
first
but
iteration,
you wouldn't use for now the semantics of the word. So you do TF-IDF. So you basically look at the frequency of the word in the specific ad compared to the frequency of the word in the entire text data that you have. The
yeah,
distribution. The
yeah, you're right, you're right. Yeah, so for now it will be just
okay.
like this. Yeah,
So
yeah.
it's probably a
So
word that is not appearing that much,
not
hopefully.
what? I'm
That is
sorry.
not appearing that often.
Yeah, yeah. So we will try to find like the words which are really specific, not popular in the whole data set, but are present in this exact description.
Perfect.
Yeah, and yeah, and I mean we will have by these we will have a lot of vectors of different words, and we have to combine them in one vector for one description, and that is another thing how to do it. I guess we start slow, so let's just average it up. So we will have all the words will be averaged, and this will be the vector of our text,
Mhm.
which will be like some amount of numbers. And I guess it's okay to put it to the same model as, for example, the one hot encoded class of the model. Yeah, I mean, yeah, I'm starting slow. So let's say we have a logistic regression,
Mhm.
and one input will be this embedded vector. Another input will be a class of the product. Another input will be the mobile phone number, also probably one hot encoded. And then then we'll train a model, and it will output us something. Um, yeah, I guess for logistic regression, it might be pretty a tough task because of all the different scales. Maybe I would go right away for at least random forest, because yeah, we're trying to combine an embedding from a text description and uh, categorical features, let's say.
A binary classifier in general.
Yeah, yeah.
Okay.
Binary, you mean that
So we
outputs
have
like
to classify.
either one or zero, yeah.
Mhm.
Yeah, any of them. So I guess this is the first idea, which is the easiest, trying to incorporate the metadata and the text description.
I have a question here,
Mhm.
which is if we have trust in humanity, we might have an issue with this data set.
If we have the trust in humanity,
Mhm. If we have
um,
collected this data, we have labeled them as good or bad for like a month.
mm, you mean that things change, or
No, I mean that it might be that we have very little bad items.
yeah, this will be in any ways this data set or the problem has a very imbalanced data set. Yeah, you're right. Yeah, that's definitely worth mentioning. So yeah, we're predicting something that is potential and hopefully is rare, as you said, that humanity is good, hopefully. So that means that we have to take it into account in our model. I don't know like the exact percentage. Probably it will be like 1 to 99. So like one positive events for 99 negative.
Yeah.
And yeah, that means that for training we probably have to somehow manually either. So we do either. Yeah, I mean, so one thing is we can do nothing. We can just train on our existing
And see how
data.
it goes. Yeah.
Yeah, other thing we can upsample the positive class. I mean the bad class. So from one to something, and then train a model. Another thing is to downsample the bad class, so not to get not all the negative problem, to get not all the non-fraud items. And I personally will prefer the second one, so downsampling, because for upsampling we either create like how to call it, not real, simulated data, or we just double or triple the existing cases, which is good when we don't have anything. But I think since we're a marketplace, we have quite a lot of data, and I would prefer to downsample the negative class.
Mm-hmm.
And I guess I would downsample it so that the training data set will have at least something 15 to 85 or 20 to 80.
Mm-hmm.
Yeah. And yeah, here we should be careful because it might affect our metrics, because the metric will be based on this model and the reality will have us different proportions. Yeah, I mean, for now, I just leave it.
Okay. Which metrics?
Yeah, so as you know, my favorite classification metric is area under the curve
Mm-hmm.
for ROC, area under the curve. And to my opinion, it's quite controversial, but still I think that it's kind of it doesn't depend on the imbalance, on how imbalanced it is. Uh, Still, maybe it is a bit affected, but anyways. So I will prefer to look at the area under the curve. I won't go to precision recall for now or accuracy. Especially accuracy is quite useless in this kind of task. It will be always close to 100.
It's almost always useless.
Sorry.
My head is almost always useless, but yeah.
Yeah.
But yeah, okay. So you go under. You are trying to maximize the area under the curve.
Yeah, for now, yeah. I mean, it's
Okay.
definitely. I have to
To
mention
pick
that
a
this.
model to pick your
Yeah,
predictors and to decide which kind of classification model you want to use. You are maximizing the area under the curve. Okay.
yeah, exactly. Like at this stage, like which is a technical
By the way,
stage. Yeah.
Alina, hi Alina. Alina says you got this.
Oh, we got this. Hello, Alina. Yeah. Right. So yeah, for this technical stage, I would get the area under the curve and see how it changes from my logistic regression and random forest and maybe something more fancy. But yeah, maybe it's worth mentioning now that when we will go to the real task, I guess we have to look at this precision and recall. And here I'm not even sure what is better, because on one hand we have to have really high precision not to allow bad products live, but on the other hand we will annoy our customers if we will try to put everything on orange or red.
Yep.
And yeah, I don't know what is the ideal solution of it. Like to pick something in the middle. Yeah. Okay, so area under the curve for our model. And we have the first very simple model with TF-IDF and some categorical features.
Okay.
Yeah. I think
So
the next.
once you have this model, so you have the training data, you have built your model, you're satisfied with the area under the curve. Then you pick the threshold based on how much weight you're giving to keeping everyone safe or annoying the customers, which I guess
Nicely put.
is the way to put it. And
Yeah.
so how do you actually deploy this model, and like how do you use it?
Mm-hmm. Yeah, right. So yeah, as we talked before, it should be something which takes or jumps into the game right away. So when the person
Mhm.
clicks the upload button, so that means that this model should be deployed and accessible live.
Mhm.
So I guess let's say we have some training service which worked on the part that we talked before, and as a result, it has the model which we will, I guess, register somewhere in some registry, but it doesn't make sense. So it doesn't make a lot of difference now. So we will get this model and put it to some endpoint, which will be accessible by a REST API call, as usual. And every time the new customer clicks on this button, upload, so this call gets all the data from the product that we are about to sell and send it to the model, not first to the model, to some preprocessor, which will process these features and make them accessible for the model, and then the model will get these features and score them and output the result. So this result should go to some post-processing system, and if it's below this threshold, when we don't want to piss people off, it will the model the model will say it's okay to put this product to the next phase, which is probably live. Otherwise, there are two gates. So if the probability is very high, again we probably need the second threshold. So let's say if it's more than 98%, it depends on the model, of course. It should be adjusted based on our data set. Then we automatically stop the process of publishing this product and send an email to the customer saying something that please double check and so on, or contact us. And if the probability is somewhere in the middle, so let's say from 60 to 95 or 70 to 95, then this is the use case for manual double checking. So we say to the customer that I think we should say something nice, not that we think that you are trying to sell the gun, but just saying something that we are running pre-moderation. We want to be super safe to the customers. So please give us some time. I don't know how much time, 3, 4, 5 hours. And we will check your post and we'll edit if everything's okay. And in this case, we have to really control how many ads we get for this manual checking. So the number of, like, the manpower should correspond to this. And I guess this also will be an important signal of this threshold. So if we take like from 50 to 95, we have just too many products to manually label. And probably in this case, we have to do like 50 to 90 to automatically put more to red. Okay, so, but coming back to the model. So the model is sitting on this endpoint, accessible by the service that tries to publish the product.
Perfect. Sounds. And are you collecting then the feedback? Are you collecting the output of these models?
Yeah, that is sure, you're right. So we definitely want to collect all our traces. So we want to collect the incoming features. So even if we don't publish the product, we still want to collect it in our data set, like as unpublished, or it will be a good example for the model in the future. And we want to collect the output of the model. It should probably go to some specific table in the database, which will be for different models, because I guess we will change models quite often. And we have to think of some nice registry of how to know what is what. And also, we will have to store this kind of conversation from the negozio to the customer. So if the model says so if we save the model input and the output, and then the customer says that, well, I think you're wrong, there is no gun, it's just your issues, we will also save it as some kind of feedback, and it will be the manual labeling based on human feedback. It also will go to our training data set.
Okay. And one thing that we didn't use is the image. So how would you use the image? If, let's say, we are not satisfied with our model, also, one can write, for example, a description that doesn't really correspond to the image and so on. So how would you insert the image in?
So that's a very cool task. Again, I will start slow or simple, let's say. So we have before we said that we turned our text into an embedding via TF-IDF. So that means we already have some vector of some length. And now we can do the same with the image. So the easiest way is to get our image and to feed it in some pre-trained model, which outputs some kind of a vector. So let's say if we take the model, like the model which is trained for ResNet dataset, usually you input something, any image of a specified format, and then it outputs you a class, which is usually like one of 1,000 classes, I guess, like cats, dogs, birds, and so on. But what you can do, you can get rid of the last layer and take the bigger vector as an output. So I don't remember exactly. It depends on the model. So let's say if you get rid of the last layer, you will have as an output a vector of length to 512. And then you can put this vector to our model. So you can say that this is the embedding of the image, and close to it is an embedding of the text, and then you have these categories. And the idea is to put them into one model. But here is, yeah, he will. It's not that easy as I am just saying, because, for example, logistic regression will definitely struggle with that because the vector is scaled to be to have quite small values.
And
And
also,
so,
you said this vector has 1,000, more or less
yeah.
1,000 features. So you
Mhm.
need to have you have additional 1,000 parameters.
Mhm. Yeah, I mean the very simple solution will be to just to take separate images separately to convert them into this 1,000 lengths vector, and then try to build the classifier only based on this. So we predict only based on these features, and as an output we'll have the probability. And
Mhm.
then we take this probability and use it as a feature for our combined model. So this is the easiest solution, which is probably not very precise, but it could be a nice start. So in this case, we will have just one value specifying the image entities and so on. Yeah, I think it will work on some level. I guess we could test it at the first iteration. But of course, it's nicer maybe to have some. I forgot all the names of these models. There are like specific architectures how to embed it. But basically, you have a deep learning model, and so one of the input is an image, another input is a text, and the other input is this single category values. And then your model processes these inputs a bit differently. So the image it does this usual computer vision. I'm forgetting the words.
I also don't know.
Convolutions, yes.
Okay, yeah.
Yeah, convolutions, yeah, and it convolutes it to something which is usually used by CV models. For the text, it does usual text preprocessing, and at some moment they will be more or less of the same length, depending on how many layers you put, and then there will be some layer which will merge all these different inputs. And this layer will be responsible for making them the same scale and the same kind of importance to each other. And then after we put a couple of layers to kind of do a next spaghetti out of it. Yeah.
Yeah, okay.
Yeah. So a bit fancy, harder to check and so on. But still, it
And then
should.
you have a vector where there is the image
Yeah. And then,
text,
yeah, at some
image
stage we will
feature
have, yeah,
at some
all
stage.
embedded. Yeah. And
Because the image probably at the beginning will be a matrix and then, or a
uh,
multi-dimension, an array of some dimension, and then.
yeah. An image as an input here is just square, or yeah, which has 3 dimensions.
Yeah, exactly.
RGB, yeah, probably. Yeah, so this model will be responsible for merging it and for scaling. That's why people like deep learning, no preprocessing or EDA. Model does all of it itself.
Okay.
Yeah, I think I wanted to mention something in between. So images and I forgot. Oh, okay, yeah. Let's say in this way we can combine the images and texts, and still as an output we have the probability, and our what we do with the probability still is the same. So we find two thresholds. We have this green, orange, and red. So yeah, maybe we have to talk a bit about how to validate if the model is good. Yeah, so at first we didn't have anything ML-ish, so it will be a bit hard to say whether our model is better than nothing or worse than nothing. But let's say we want to go into data-driven direction, and we'll have the first iteration, and then when we build the second model, we already can compare them with the existing ones. And of course, the first phase, how to compare, will be to compare just the technical metrics on the historical data sets. So we will just see how they perform on the same piece of history. And this is another question to define the piece of history to check it. So I guess we have to have some window back, like to look
Mhm.
at, I don't know, months back, and maybe we have to ingest some specific periods of time when something interesting happened. Um, yeah, it's just a random thought. And then we'll see the
Would
technical.
you keep, so right now you're talking of about a model that is already in production?
Now I'm just talking about like any model which is either in production or is about to be tested.
Okay.
Let's say we have one model in production and now we are testing on a new version,
Mhm.
adding like images, for example. So we
How
check
do
how
you
this.
do that? Like if you wanted, okay, so let's say you have a model in production and then you have the metrics for this model in production for,
Mhm.
yeah, as you said, an old period, and then you want to build another model
Yeah.
and decide which one of the two to,
Hmm.
like, keep going
Yeah.
with the old model, or are we releasing a new model?
Yeah, yeah. So for me, the first phase will be like to do the offline check. So not yet going online. So just to see how good the new model is on
Mm-hmm.
historical data. And if
Mm-hmm.
it's not really better on historical data, it probably does make sense to proceed further. We just do another exploration experiment. And if we see that the model shows some significant result on historical data, that's the time to think of how to test it live, like on real data. Because I think in these use cases, when you have a real system, the only way to say that something is good is just to put it in production and see how it performs. So I guess we have to implement some service for A/B testing. So we can start from A/B testing, and yeah, I mean, for A/B testing, we have to do some things. So first of all, we have to decide how to split our customers or the traffic. So it could be a 50-50 split. So 50% of the customers see the old version, 50 the new. If we're not that brave, we want to do like 90-10. But it will affect the needed sample size. So for us, when we run the A/B test, we need to collect the minimum amount of observations to make conclusions on the significance of the result. And there are formulas of how to get it. So we specify we specify kind of the current magnitude of the value that we observe. We specify how much of the difference of this value we want to observe significantly. And then this formula will kind of tell us how many observations we need to obtain to be sure that there is a difference or there is no difference. And if most definitely we want to be super sure about it, but this model will tell us that we need to run the test for like 2 years uh, because we don't have enough traffic. And in this case, we have to compromise something. So we either compromise the kind of the power of the experiment.
Mm-hmm.
So yeah, we put something live when we're not super sure, or we try to find the proxy metric. Let's say, yeah, actually, yeah, I forgot to mention this. So when we run this A/B test, we are comparing something to something. So we need to define what metric we're comparing. And um, I think it does make sense to compare this probability because probability is bound to the specific model. So it's here we have to put something like real world, like business metric. And for this exact task, what could it be? Actually, that's an interesting question.
I was wondering the
Yeah.
same because it's not that we, with our model, are impacting the behavior of the customers. So a little bit,
Yeah.
yes, like you said, they could get annoyed,
Hmm.
but we are not testing two different versions of something that will impact their behavior.
Yeah. Yeah. You're right. So I guess what we could check is something what I don't like is a precision recall.
Yeah, but this is not
So,
something that you usually check. I was thinking the same as you.
mhm. Yeah. No, I mean, in the end, that's probably what is important for the website of how many harmful products went online. and how many non-harmful products were labeled as potentially harmful. And I guess this could be the metric which is A/B tested.
Mm-hmm.
Maybe like a typical F something score,
Mm-hmm.
F1 score, or yeah, with some weight maybe closer to precision, because I still think that precision is a bit more important.
But what I'm thinking is, yes, then we have two models for this, but wouldn't it, since, so if we assume there's no change in behavior, then this would be equivalent to do the same test offline, right?
Um, yeah, but offline we can only assume. Um, you
But
mean when we don't
if there
see
is some changes in behavior of the customers,
the customers?
then yeah, I'm just thinking out loud. Like
Uh-huh.
if we just use performance metrics and not, as you said, business metrics, what
Hmm.
is the added value of doing A/B testing versus offline testing? And if there is no change in the distribution of
Hmm.
predictors.
Yeah, I mean, if you put it like this, then yeah, then there is no way of doing A/B testing live. But I think it's valid about any kind of real world problem. So
Mhm.
if nothing is changing, then you just do offline testing.
Yeah,
But yeah, it always will change. I mean, this involves a lot of things which could go differently, like different season, different product. Yeah, actually, different products. So something new appears on the
yeah,
market
this is
most
what,
time.
yeah.
Yeah, or yes, there should be just natural drift of something, like of people changing their mood based on seasons,
Yeah.
or yeah, some specific moments when people are more active, something like this. So I think nevertheless, it's we have these historical metrics, but if we're doing something live, we have to test it because we cannot be sure what's happening. Yeah, or at least I mean, the A/B testing is not super necessary, but at least we have to track the live metrics, right, and
We
calculate
have to
this.
track, yeah, this for sure. Yeah.
Yeah, and if we see that something is going weird, then we have to look into this. Yeah.
So what could be something? So let's say we are not doing A/B testing, but we are
Hmm.
tracking our performance metric live,
Yeah.
and then different things could happen, right? So
Yeah.
let's,
Yeah.
yeah.
I guess the easiest way and the most obvious probably is to run the same calculations for the live data set. So we have the historical, precision and recall, and yeah, and then after every day, let's say, we calculate the precision and recall. Ah, right. We don't have the ground truth. Yeah, so I guess we still have to run some to sample some of the amount of our products and send them to manual labeling. And
Mhm.
this manual labeling will give us the ground truth. Maybe we do it like once a week, and then every this week we then kind of rerun the. We see how our model performs, the output of our exact model based on these ground truths, and we will have these other values of precision and recall, and we can compare them to the original train on historical data. Of course, they will be worse than historical, but then we will see how much worse, and also if they are getting worse with time or they are stable. And I guess the natural behavior will be that we see that they are going worse and worse and worse. And then some moments we have to retrain the model.
So why would the model, like, what are some circumstances in which the model would suddenly start performing badly?
I think
Like,
anyway.
just
So
test or like kind of investigate why the model uh, from last week on performed
mhm.
badly.
Yeah, I think if you start investigating this, it might be like a natural rabbit hole. There are like too many reasons. I personally I would see it as a natural behavior. So, and if I won't observe that my model is getting worse from week to week, I will be also worried. I think it's just natural. So you train something on the data which is in T0. Then 1 week passes, something happens with people, with society, with products.
Economy,
It's
yeah.
already yeah not that precise as we trained. It should be worse. And then the more we go into the future, the more uncertainty and some new potential weird things are inserted into the data and to the behavior of people, and it should deviate more and more from the data set that we trained on. So this natural data drift, I would say. And this, like our model, involves real human behavior, so it's not something only manipulated by machines. And humans always change in different aspects. And also we have our marketplace, I guess, I hope will grow. And at first we have like 10 categories and we have 20
Yeah.
categories and we introduce subcategories and new meta features and so on. And we will have to change the models to get
Yeah.
more features. Yeah.
So more variety also in the customer base. Maybe at the beginning is a niche, and then
Yeah. And then some very famous fraudster will register on our website and we have to find them. Yeah. It's
so let's
difficult.
say we grow a lot, and then we kind of our data becomes even more heterogeneous. And yes, we had these labelers, the labeled data, but the data they labeled was is not significant for the new data. And now we don't have time and we don't have money to label more
Mhm.
data. Like, can you think about one approach that we could use that, let's say the holy grail is to have label data, but right now we are growing, the model is doing very badly because it is, and we have a lot of data, the model is super unbalanced, so really we have few instances of bad items, like, and
Mhm.
we cannot afford to label the data, just
Yeah.
the approach we could use.
Yeah, I guess we can use something like I don't know, it's called human in the loop or so. So we first
So
we
let's
can
say
run
we have
up.
no humans at all.
Sorry,
We have no humans.
no humans at all.
Yeah,
Um, a human, no humans to build to bring us the ground truths.
yeah. No ground
Okay,
truth,
that's
just the
challenging.
data.
Yeah, that's
No
challenging.
labels,
No labels, right?
no supervision.
Yeah. Well, I mean, still we can calculate the drift in the input features and in the output features of our model. So
There's no model anymore. This model is just not working. We threw it away. It's a mess.
you mean we throw it away in what sense? From the online?
Yeah, we
Or-
like the model is not working anymore because we have a huge customer base.
Yeah,
The data we trained the model on were not representative of the new data. And
yeah.
now we have a lot of data. So images, text, metadata. We have no labels whatsoever.
What to do?
What to
So,
do?
I guess we're at square one again.
Yeah, it just happened.
Yeah,
Surprising. I mean, it's good for us because we grew a lot, but yeah. And then we say, okay, this model is not recoverable. We can't do anything with this model.
yeah,
We need to just think about out of the box and think about something
yeah.
that tells us, hey, this could be a problem. Uh,
Mhm.
Keep in mind that we overall trust our customers and we know that the fact that a dangerous item is posted is very rare.
Mhm. Yeah, I mean, in this case, if we have a significant history of some customers posting only good stuff, we can, for example, automatically pass their new sales from them and mark them as green. And then we have to introduce some feedback system, like reporting system, so that the other customers could report on the goods of the others, telling that there's something potentially harmful. And we could use this data for our models. But again,
Or
if we don't,
just
yeah.
a different model we could use.
I mean, yes, you said our previous model has to be thrown out. It's like useless, and I think so. Anyways, we have to come up with a new model, or maybe
Yeah,
a couple of models. And still, this model or models they need some historical data to be trained on.
but no labels.
You mean you kind of pushing me to the unsupervised data?
I
Okay.
am, I am.
Okay. Yeah. I mean, this could
What is
also
your
be.
opinion on that?
Um, yeah, I mean, we could use some unsupervised approach and try to find, I don't know, cluster and find and weird clusters of products.
Mhm.
Yeah, I'm just thinking of like how to come from this technical side to the actual solution side. Because on technical side, we will just see what is weird, but then we will need people to look at these weird classes and see is it really what we want to find, or if it's just specific features that are not rare or not oftenly seen in the data set.
Yeah, I agree.
Yeah, I guess this could be an approach, but I personally would probably try to maybe hire some people to label the data and to go via supervised stuff. Yeah, but this could be a try. Try to cluster things and see what's wrong. Yeah, I actually never thought about this in a similar context. Yeah.
I was thinking, for example, so we have a lot of data and they have a certain distribution, right? And we receive the new data point and it fits perfectly under this distribution. If we
Hmm.
transfer most of the data, the most of the items are good,
Yeah.
then we would say, okay, this looks like most of the items. And then we get a data that doesn't look like most of the other items, a data point,
Hmm.
right? So an item that's like, oh, this is really weird. Of course, it could be something that is just very like a
Yeah.
flowery curtain that didn't appear before, right?
Yeah. Yeah.
And then you're right, we would need some humans to say, no, this is actually just something weird, but not
Hmm.
something dangerous.
But I guess we can do something similar without throwing our model away. We can just look at the incoming features, and so these features they also have some distribution,
Mhm.
and we can see how these new incoming features are different from our historical distribution.
Yeah, yeah,
Yeah.
yeah.
Yeah. And also the same for outcome of the model. So if we see that before we usually predicted like this amount of green, this amount of orange, this amount of red, and suddenly the red goes higher or lower, which is risky, then it's also something to be aware of. Yeah. But I hope this won't happen, what you tell, that we grew fast, we have a lot of different areas, and suddenly we don't have a model. This will be a really
Really
bad
bad.
occasion. Yeah.
Yeah.
Right. Yeah.
I think
What
we're
is
almost out of time of our interview,
Yeah,
but
you're right. You're right. You're right. So I guess that should be it. And if I forgot something, that's
thank you
my
for
fault.
building a machine learning model for negozio.
Yeah, no worries. You're welcome.
Negozio.it.
Yeah, and thanks a lot for guiding me. A lot of nice things that you poked me
So
into.
just to sum up, so for if there was a new company that wanted to start using machine learning for this use case or for any other use case, what would you suggest?
I would
And
suggest,
should we hire people like you, or should we try to have our IT people build something like kind of infrastructure? Just any
uh,
suggestion?
it's a controversial question. uh, I guess, I guess you could, if you're a small company, you could. Hmm.
Do it yourself. Hire a
Yeah,
consultant.
yeah. I mean, I'm thinking
That might be too
so.
expensive.
Yeah, it might be too expensive. Maybe you could hire someone who is a private consultant who can be not that expensive and who is a bit more flexible and who can look into your data and quickly tell you whether this quick solution of, for example, TF-IDF without images could work for your case. And if yes, then you can hire some. So either if your engineers are interested in doing some machine learning, they can do it. But I guess it's easier to or safer to hire maybe one experienced person at least to guide them,
Mhm.
and they will implement the model together. But still, I think if you are this kind of a company which has a lot of customers and you know that you will need this model in the future and you want to grow and this model will grow and it will have a lot of things to track and to improve, I think it makes sense to hire at least like 1 or 2 people around this area so that this expertise becomes in-house.
Cool.
But I'm not a businessman, so
I will then.
yeah, you can hire me as a this person, as a consultant. Perfect. Thanks a lot, Annalisa.
Thank you.
Yeah.
Any feedback on your side?
I really liked how you did it quite smoothly, and sometimes you really put it like in a way that I haven't thought about, which is important. So thanks a lot, not stressing me out and guiding me to,
Stressing.
yeah,
Okay, cool.
to new things. And I hope that your Nikot's startup will really rise and
I hope
become
so
a unicorn. Yeah,
too. Not too many dangerous items.
yeah, and people will stay happy and satisfied. Great. Yeah. So thanks everyone who's watching.
Thank you, everyone. Have a good weekend.
Yeah. Have a good weekend and see you in our next sessions. Bye bye.
Bye bye.